Let's discuss three problems. All are backtracking pattern. Leetcode 17, and then Leetcode 78, and then Leetcode 90. Leetcode 17 is basically given, say, for example, 2, 3 number. You need to generate all the combinations from the digits to the letters, basically. So in the case of 2, 3, you need to generate all these things. 2 represents ABC and 3 represents DEF, so you get all these combinations. So whenever there is combinations are needed, you use backtracking pattern. And same case with subsets. You're given 1, 2, 3, you are supposed to generate all the subsets. And then 90 is same as 78, but the duplicates are allowed in the input set, but you cannot have duplicate subsets. Basically, you cannot have 1 2 twice if you're not careful, and then 2 2 twice. So those are the three problems. But more than that, I think I'm doing this video to tell like why other YouTube videos show that lead code patterns is all you care about, and once you learn like 8 or 15 patterns, then you don't have to worry, you don't have to do all the lead code problems. If it was only that easy as they claim, and I'll show you in this video that they are not giving the complete information, we don't need lead code accounts at all, right? If they were right, all you need to do is spend like one day or one weekend to learn those 8 patterns and you are done with. So it's not as easy as they claim. And so I want to show why patterns, what they say, are not as easy as it looks. So let us take a look at the solutions. So I actually wrote a common code, especially for the backtracking for all these problems. And if you see whatever the pattern they claim in the YouTube videos, it represents only these 3 lines. That's it. So it's the same backtracking used for 17, 78 and 90. And even here also there is a lot of parameters you have to pass. So each problem has its own nuances, and so the backtracking pattern they claim is just these 3 lines. You push a current thing and then call the general backtrack and then pop back, so to get all the combinations. And so just knowing the pattern is not sufficient. Look at the amount of lines of code in order to accomplish all the 3 problems. Each one has its own nuances in a certain way. Even the problems 78 and 90 were pretty similar. It needs some special handling for 90 kind of thing. So the claim that you just need to learn the patterns is not true. They're not telling the complete truth. So let us take a look at this solution from let us go through this code one by one, line by line, so that way we can see. So this is a generic backtracking function. So I had to add a lot of additional variables to accommodate each and its own problems nuances. So in the case of 78 and 90, you are supposed to give uh, not just the entire set, you have to give the subsets also, whereas in the case of 17 you cannot give only the 2 letter combinations. When you are backtracking, you get single letter combinations just like subsets you get, but you cannot take the subsets of a b a. You have to give basically, I'll show you here. So in the case I need to use the fixed length. So in the case of 17, the fixed length is the size of the actual only added when you reach the length. So if in the case of 2 3 you can only add ab, you cannot add a or you cannot add b, you have to add ab. But in the case of subsets, you need to add empty set, you need to add a, you need to add b, and then you need to add ab. So this is one nuance, and within you go through the list of choices, and for each choice here a template is needed because of there is the different data types. One is a character data type, the other one is a number data type. So you could have avoided that, but let's continue. So for the case of 90, there's like you can have to for 78 you don't need duplicate handling, but for 90 you need duplicate handling. And look at this nuance too. If you need to for the problem 90, you need to check I equals to I minus 1 only if I is greater than index. Otherwise, if you don't do that, it becomes a problem like 78, where you don't allow, even though it is given, say for example, the subset we'll saw on the Leetcode website was 1 2 2, and if you don't add this one, you don't let the first set of the duplicates in, this what controls, like you don't allow the second set of duplicates, but you allow the first set of, if you have a duplicate thing like 1 2 1 2 is the set of duplicates, you allow the first 1 2 and then stop the second 1 2. And so this is the generic backtracking pattern everybody talks about. So now that is the general backtrack which we use for 17. So for the letter combinations, see this one has its own, you need to understand everything, like you need to declare this unordered map of mapping from letters to from mapping from digits to letters. And now you go through this, you build the choices vector for each of these things, and then you call the generic backtrack with the specific choices. These are the choices, this is the running one, and this is the index, and this is the result where you capture everything. And then this is fixed length is true, and you don't need duplicate handling. And then finally you get the you go through the result, and then push back the final result in the case of 17. In the case of 78 and 90, the code with or without duplicates. So look at the bool no duplicate handling, and if there is negative of no duplicate handling, then basically means you need to sort. In the case of 90, you need to sort because of you need to handle duplicates. You need to sort them so that I equals to I minus 1, as we saw above in the general backtrack function works. And once again you build the choices like we built on the for the problem number 17, and then you call the generic backtrack. And so now you run the test case digits equals 7 23, and then you call the letter combinations function. And then for the case of 78, you don't need to hand duplicates because they are unique numbers, as the Leetcode problem number 78 says. Here there are duplicates, so here you need to no duplicate handling true means no duplicate handling, and no duplicate handling false means you have to handle duplicates. And I have the sample runs from this one, like for 17 how it is going through. There is a separate video for 17, I think we can check. So finally we come up with the letter combination. See, you have to have the same length as the input string in order to for 17, but that is not the case here. 1 2 3, you don't only add 3-digit, so you do 1 2 3 1 2 and all the empty sets and all. And in the case of 90, you do this 1 1 2 and all. And this was out, if I is not greater than start, if you remove it, it becomes like 78. Even though it is 1 2 2, it becomes, it allows only 1 2, because you're stopping, squashing all the duplicates, and this is what you will end up with, and this is what you are expected. There are separate videos for 17 and 90 if you want to check it out for more detail. But the 78 one is this video. I don't have a separate 78 video, which I'll make it in the future. Comment below if you have any questions. Otherwise, I will see you in the next video. Bye.